Ladies and gentlemen, hello. Here is a presentation on how to improve your user experience with the i3 Window Manager by using scaled floating windows. That's right, I said scaled floating windows. Before we get into the details of that, let's talk in general about the i3 Window Manager. Why I use it, why you probably use it, and if you don't use it, here's why you should. i3 efficiently uses screen space. It automatically manages the size and placement of windows according to how many windows you have open at any time. It can render windows in flexible layouts, tiled, tabbed, stacked, and also floating. i3 uses minimal system resources, including the extra wrappers and helpers. It takes about 5 megabytes of RAM, and on disk, those files add up to about 1 megabyte. i3 works, and quickly. It's tweaker friendly. You can extend its functions. You can make it work the way you want it to work. i3 is minimalist. It is not a desktop environment. i3 renders windows. It has limited styles which are configurable by you. You can configure gaps, titles, window borders, size and colors. i3 has extensive keyboard and mouse key bindings. That is great because in i3, you do not have to go to the Start menu to bring up your favorite applications. You associate them with hotkeys and mouse movements. So you can very quickly open, close, and move around your applications to one or many workspaces in the system. External application color schemes and styles are not managed by i3. You will rely on GTK, Qt, or other theme managers. Float is up to you. You can have none, a little, or plenty. There are a lot of users who have the absolute minimum software on their machines. They work very quickly, very efficiently, in a bare bones manner. There are others, like myself, who keep a somewhat deactivated desktop environment on the system. I use the Mate desktop environment, but I've got most of the features turned off, and I simply call the applications a la carte whenever I want to use them. The floating window feature in i3 is minimalist by default. It is selectable by key bindings such as Shift, Mod 4, and Space. If you're not familiar with Mod 4, that means the super key or the Windows key. So that combination will cause a tiled or tabbed or stacked window to pop out of the normal layout and float above all of the other application windows. You may also use the config file to set up your floating windows so that certain applications by default open in floating windows. That's done using the floating enable and for window statements in the config file. Floating windows can be resized with the mouse or the keyboard. One downside to the rather minimalist floating windows in i3 is that the feature is prone to glitches and slower speed in the case of setting up many floating enable or for window statements. Those cause the config file to become rather large, and it becomes rather cumbersome in the software. Developer policy prioritizes tiling and not floating windows in i3. If you look into the i3wm issues on GitHub, if you read the threads on Reddit, you'll find users with minor gripes about the floating windows, and the most common response is, well, i3 is a tiling window manager. We're really not interested in putting a lot of work into floating windows. So you may ask why persons such as myself insist on better floating windows in i3. You want to know why i3 works great for so many other things. When it comes to floating windows, the default floating windows suck. I say again, they suck. We're going to fix that, or it will never get fixed. Let's talk more about the wild-ass i3 floating windows. By default, floating windows render without control of size or position. They are often too large or too small. Sometimes they're centered, sometimes they are not centered. That's because the developers have left it up to the applications themselves to control where and how they render. Unfortunately, a lot of the application developers leave it up to the window manager or desktop environment to handle that, so nobody seems to care. This, despite the fact that i3 has the screen dimensions, uses those numbers for tiling, and with a few lines of code, it could scale and center the floating windows and save everyone quite a bit of headache and heartache. Let's take a look into the i3 config file code. In the upper block of code that you see here, we toggle floating for the focused window with either of two key combinations. One of them is super shift space, and the other is super and right mouse button. Those will cause a tiled or tabbed window to pop up out of the flat layout, and the floating window will occupy the screen on top of other application windows. In the lower block of code, you'll see what's written into the config file to enable floating by default for specific applications. The line will start with a for window statement, and in brackets the class name, and then a command after that. So for Firefox, you can see from left to right, it's for window, class equals Firefox, floating enable, and it's the same kind of code for GNOME terminal, Kaja, and whatever else the user might want to float by default. It's also possible to float all windows by default with one line of code using some regex in the class statement. In that case, opening any application will cause the window to render as floating. In my case, I keep most of my applications either tiled or tabbed, and I only have certain ones that by default will pop up as floating windows. I initially started with code in the config file, similar to what you see here. I found that there was a better way to do it. Budlabs posts a lot of videos on YouTube and probably elsewhere on the internet, and he has worked out a lot of the kinks in i3, and he's very good at making Linux systems run very nicely. For our purposes, the most important 3 videos on his channel are Let's Linux number 3, i3wm, how to set all windows floating in i3wm, and Thunar number 3, using i3IPC Python to update tab title. So with i3IPC, you can add some finesse to the function of the system. It's not just i3 Python that you'll use, but also a listener script. That listener script will monitor and modify i3 interprocess communications. It can intercept and change window titles. It can cause certain windows to float. It can leave other windows tiled or tabbed. It's also possible to include other features that are unavailable out of the box in i3. Let's look at Python code in the i3 listener script. This code floats windows. Up top, there's a function which actually sends the command to execute the rendering of a floating window. Event container command floating enable. Now, in the lower block of code on this slide, you'll see what detects the arrival of a new window and what sends the command in the script to run that function that's up top. So on window new, set floating. It's that simple. The script will detect the opening of a new window. It will cause that window to float, and then the script will go back to monitoring and waiting for another new window to arrive. In order to float specific windows instead of floating all windows, we need to make the script more complex. Here you see two blocks of code. The upper block has a variable called floaters and a list of window class names. The lower block of code contains the function, which is a bit more complex than the other one in the previous slide. Here, instead of simply floating whichever window is sent to it, it's going to check the list of floaters. And if it finds a match, it will then direct that window to float. In addition to floating the window, it will resize the window to 1000 pixels width by 700 pixels in height. That's a hard-coded size, 1000 by 700. And it will direct that window to be rendered in the center of the screen. Once it finds a match, it breaks out of the list, and the i3 listener script will go back to monitoring for subsequent new windows. That's better, but it is still a bit rough around the edges. We can now control floating window placement, size, and centering, but the size must be given in specific pixel dimensions. Thank you to the developers of i3. We'll specify specific pixel dimensions instead of a simple proportion of the screen, right? That's the problem. Here's the issue. Hard-coded resolution does not scale for higher or lower resolution screens. There is a better way, and here are the steps. Determine the actual screen resolution. Specify a desired window size as a percentage of the total screen size. Scale the floating window to the desired size. The size should be easy for users to set. The size should change automatically if screen resolution changes. Put it in more practical terms, the user should be able to write into the i3 config file a scaling factor for floating windows, whether that's 50% and 50% for width and height, or perhaps 75% width and 90% of the height, whatever the user actually wants for their system. They should be able to write it into the config file and let the software handle things from there. There are several ways to programmatically obtain the actual screen width and height. Since the i3 listener script is written in Python, A great way to do it is use a module called PyAutoGUI. PyAutoGUI is small, efficient, and easy to install with pip. It's necessary to use one line of code to get the information. Then, simply multiply the screen width and height by the desired scaling factor, which comes from the i3config file, and apply the product as variables to resize floating windows. The i3 IPC listener will do the math and execute the positioning and resize commands. It is necessary to make some changes to the i3 listener script. We want to import PyAutoGUI and import sys. Once the modules are imported, the script then connects to i3 and sits in listening mode. It pays attention to what i3 is doing and waits for a window event to occur. The lower block of code works with variables. First, the screen width and height are retrieved by PyAutoGUI. Then, the window width and height are determined. Essentially, the screen width is multiplied by a scaling factor for the width. The screen height is multiplied by a different scaling factor. Thus, the window width and window heights are determined. Remember that those scaling factors come from the i3config file. The user can edit those to whatever he or she wants for window dimensions. The i3 listener script is going to use a new function to manage floating windows. The top block of code shows the actual command which will be sent to i3. It will direct i3 to position the floating window in the center of the screen, and it will resize the window according to the width and height that were determined earlier in the script. The function itself is in the next block of code. It's called window resize, and it looks pretty simple. Event container command, and it sends the window command. Window command is that long string at the top of the screen. In the third block of code, you can see that the i3 listener script simply waits for a change to the floating status of a window. If the window is floated or unfloated, it will trigger the window resize function above. After the instruction is sent to run that window resize function, the i3 listener script uses the bottom block of code. It simply goes back into listening mode to monitor for more i3 events. Of course, if there's another window floating event, the window resize function will be triggered and the instruction to center and size a floating window will be sent to i3. Now you might be wondering, if that instruction is sent to i3 when a window is floated or unfloated, well, what happens when a person unfloats a window? What happens when the window is pushed back down into the tabbed or tiled layout? What happens when that command goes back to i3? It turns out that i3 simply ignores the command. The window is no longer floating, so it will not resize and it will not do anything to a window which is taken from floating back down into the tabbed and tiled layout. It simply throws that instruction away, can't do anything with it. So the only instruction that really matters here is the instruction to move a window from the flat, tabbed, tiled, or stacked arrangement and make it floating. Only when a window is made to float does the center and resize instruction matter. So that code is probably not the most elegant and efficient code, but it works. What are the results? Smooth, fast, no-hassle scaling. Proper scaling begins at first login. Scaling reinitializes whenever i3 is reloaded. If you change your screen resolution, reload i3 or log out and log back in. If you do that, i3 will start up again, it will look at the config file, and it will redo the math and determine the proper dimensions for floating windows. To change the scaling, edit the i3 config file, and then reload i3 or log out and log back in. When you get tired of this kludge of code, tell the developers to improve the native floating window behavior in i3, and we'll all be happy. Here's a picture of my desktop. I've got some code brought up in i3wm. You can see some very pretty syntax highlighted snippets of code. The editor screen on the left contains code from the i3 config file. The top block of code shows the key combinations used for toggling the floating of windows. Use the key combination or mouse and key to pull a window out of the tabbed, tiled, or stacked arrangement and make that window float. The same key combination will push that window down out of floating mode and send it back into the tabbed, tiled, or stacked layout. The bottom code in the left editor window is again from the i3 config file, and it shows the instruction used to start the i3 listener. The two arguments at the end of the command are the scaling factors. The first one is for width, the second one is for height. So we're looking at a width scaling of 75%. The height scaling is 85% of the screen height. The editor window on the right is in fact the entirety of the i3 listener script. See the imports in the first block of code? And then moving down, there's an instruction for the script to go into listening mode. There are lines of code to work with variables. First, to assign variables for width and height of the screen using the PyAutoGUI module. Next, there's a bit of simple mathematics to multiply the actual width and height by a scaling factor. Remember that scaling factor comes from the i3 config file, as you can see on the left, those numbers. With the dimensions of width and height for the new window, those go into the window command. The window command is a long string. It's all prepared, and the script simply waits for a reason to use that command. The function is a simple two-line block of code. Define window resize. i3 and event. Event container command window command. That's the function. It's two lines of code. Moving down, you can see that the i3 listener simply monitors the i3 inter-process communication. And when it finds a window has a change to its floating status, then it invokes the window resize function. After it sends that, after it runs the window resize function, the script goes back into listening mode. And that's it. That is it. It might be a bit crude, but it works beautifully. To me, it doesn't matter anymore if the i3 developers don't do anything else with floating windows. I've got it taken care of. I hope this presentation is helpful to you in enjoying better floating windows in i3 Window Manager. Nothing's perfect, nor need it be. Small, focused, efficient add-ons can fill in the feature gaps. Here are some references. If you want to read and study further, look here for info about i3wm, straight from the people who create it. Ditto for i3 Python. Here's a URL for the i3 Window Manager subreddit. There's also a URL for the Budrich github.io page. I would also recommend that you find Budlabs on YouTube. Watch the Budlabs videos. He's got great material. You'll learn a lot about i3 and coding, and he's fun to listen to. Last but not least, my GitHub repos. github.com/AB9IL. Alpha Bravo Niner India Lima. This presentation is a production of YouTube channel Mach 7 Radio Intercepts and Radio AB9IL. Here's the URL for my website. Alpha Mike Foxtrot. I won't say what that is, but you can look it up on the net. Everyone, enjoy your day. Bye-bye.